Dagster provides powerful orchestration capabilities that let you schedule your dbt models alongside other data assets. But that's just scratching the surface of what it can do. Dagster is built to provide fine-grained control and deep insight into your data platform. So today I'll showcase a few upcoming features that will help you supercharge your use of dbt. We've already seen how you can set up Dagster to regularly update your dbt models. But what happens when you make changes to your models? Ideally, the table corresponding to the model would be rematerialized so that it matches our SQL change. Our downstream data, the tables, models, and reports that are built off of our model, might also now be out of date. Ordinarily, it can be a nightmare to track down and update everywhere our models are used. Let's take a look at how Dagster's auto-materialization functionality can help. Let's say we notice something is wrong in our payments model. It looks like we're incorrectly converting prices in cents to dollars. Let's go ahead and fix this bug and save our change. Because we've been computing this field incorrectly, our downstream models have also been flawed. Thankfully, since Dagster is aware of all of our data dependencies, it can automatically mark our assets as out of date. Let's go ahead and reload our code in Dagster. Dagster will automatically recognize that our SQL has changed. For those of you familiar with the state-modified dbt selection, this works in a similar way. One difference is that Dagster will mark out of date all affected assets in your data pipeline, not just those written in dbt. Here, we can see an asset which uses Python to generate a report shows is out of date too. If we wanted, we could now manually rematerialize our assets to bring them back up to date. Coming soon to Dagster is the ability to, if you so choose, instruct Dagster to automatically recreate models and their downstream assets when their SQL is changed. Instead of manually rematerializing our assets, we can see that Dagster's auto-materialization functionality has automatically kicked off a run to rebuild just the changed model and our downstream assets. We can see our dbt models, which depend on the changed model, as well as the report Python model, are being updated. Auto-materialization helps us take the guesswork out of our data platform, ensuring the data is always up to date when we need it. Dagster's local development flow is designed to help you iterate, test, and build confidence in your dbt code before you put up a pull request. Once you're ready to push your code, Dagster Cloud can help you and your reviewers build confidence in your change before merging using branch deployments. Let's say I wanted to add a new dbt model to collect all of our pending orders in one place. I've already tested against mock data locally, but I want to make sure that it's going to work properly on real production data. I've gone ahead and created a pull request. Since I've set up branch deployments on my GitHub repository, Dagster Cloud has created an ephemeral, sandboxed environment where I can test my code. Opening up my branch deployment, I'm greeted with an asset graph which now shows my new dbt model. This is an ephemeral environment, which coexists alongside my production deployment. It's running against a copy-on-write clone of my Snowflake schema, so I can kick off the materialization of my model, which reads from real production data, but without having to worry about anything being written to production. Once my run completes, I can head over to Snowflake and query the data that I just produced, which was sourced from real production inputs, but is output safely to a clone of my schema. With confidence that my change works properly, even against real data, I can now merge to production without worry. Dagster's role is not only to orchestrate computation of your data, but to provide you deep insight into what's going on in your data platform. For many data teams dealing with scale, tracking down resource usage and cost is a priority. When you have a lot of stakeholders who are building and scheduling computations, it's not always easy to get a handle onto where to focus your effort to save money. For these users, we're building a feature for Dagster Cloud that helps track down sources of wasteful compute and spend out of the box. Let's say that I'm a data platform engineer, supporting a team of other stakeholders who have built jobs using dbt, Snowflake, and other tools. A recent budget review meeting showed that our Snowflake bill has been spiking recently. Let's go to the new reporting tab on Dagster to get a handle on what's going on. There are a couple different ways that we can investigate. Dagster provides a way to filter jobs, assets, and asset groups by costs like Snowflake credits, or by performance metrics like compute time or number of retries. Since we're looking at a Snowflake billing change, let's go to the Snowflake credits tab. It looks like one of our asset groups has had a major increase in consumption over the past couple days. Let's drill down into that asset group. First, maybe let's see if any of our assets are being rematerialized more often. Though it seems like the rematerialization count has been the same. Maybe let's look at duration instead. It looks like one of our assets, orders, has increased in runtime pretty significantly over the past couple days. If we hop over to the Snowflake Credits tab, we can see that same orders asset is responsible for a major increase in Snowflake credit consumption. We can click over to the asset in Dagster's asset catalog and jump to the asset's definition in our GitHub repo. Let's tab over to the Git blame and see if anything has changed. It looks like someone has recently changed the dbt model to add a pretty expensive join. This seems like it might be our culprit. Now, we can contact the team responsible and let them know about the regression. Hopefully this gives you a taste of some of the powerful features that Dagster has to offer on top of dbt, which let you not only better ensure your data is up to date, but also get insight into all that your data team is running.